So, if you watched my previous video about the supercharger, you'll probably know that this one was removed due to excessive oil consumption, and it turned out that there's a lot of play in the bearing like that. So I'm going to whip it apart and we'll have a look at what's wrong with it. Okay, so there's nothing immediately obvious wrong with this end of the shaft at the moment. This is the ball race and feels okay. It's got quite a bit of movement in it, but that's because they are a high clearance bearing anyway. That might have some wear on it possibly, which is increasing the movement on the shaft. So the bearing sits inside this sleeve, which then presses into the casing, and it is the intention of this is to try and keep the bearing a tighter fit to prevent it rotating. And this is something that I mentioned on my previous video, where I changed over from this to a bearing which actually has 4 lugs on the outside of the outer race which bolt into here, which totally prevents it from rotating. Because you've got to remember, as the engine warms up and this casing comes up to the oil temperature, about 100 degrees C, the fit of this sleeve in here is going to be looser. There is some evidence in here that this could have been turning, and if it has, it means that it's not as close a fit in here anymore because it'll have worn the aluminium. To be fair, there isn't a huge amount of evidence really that it's been turning a lot in there. It was a tight fit when it came out, so I'm not altogether certain that that's the problem. where the bearing fits inside it is fine. All the other components which form the oil seals, again, there's no evidence of anything been touching or wearing into the casing, so perfectly happy with that. And then the shaft, the bearing, there's no evidence on this journal here that the ball bearing has been turning on it, so I think that's okay. I think replacing the bearing is definitely going to be the first thing. So that part of the casing is alright. You can see there where the labyrinth is. 1, 2 marks on there, but again, nothing's been touching, nothing's actually worn. So my thinking at the moment is that the excessive oil consumption must have been coming through from the tail bearing. You might not be able to see it on here, but there's some evidence here where the air comes out of the supercharger. It just looks like it's been very, very finely sandblasted, and that is because it was run without an air filter for the first few years that I had it, and it goes to show you that's what happens to your engine if you don't run it with an oil filter, with an air filter, sorry, because this sort of abrasive effect will happen obviously to the cylinder liners when the air gets sucked into the cylinders, and that causes wear. It doesn't really cause any harm to this, but it would erode the impeller eventually just due to the sheer speed that it's doing. So that casing's alright. And same here. Now all the damage you can see to this diffuser vane here is simply because when the engine was rebuilt originally, the supercharger had to be changed because it was too badly damaged. But for authenticity, whatever you want to call it, I just included as many bits from the original engine as I could, and you know that you can see obviously what the state of the rest of the supercharger was probably like. But I did notice, actually, you can see there's a broken vane here which really shouldn't have been left, so I'm going to take that off, and I'll probably smooth off some of the broken bits on this as well. There's definitely a danger of that piece breaking off. I don't know why I left that in there, but otherwise, again, this casing's fine. You can sort of see the sandblasting effect on there as well, and there is a little mark there around there, but I suspect that's been me turning it since I took it off the engine. So again, I think this is okay. We'll just clean all these parts up, put it together, and then look at machining the intake elbow, which is definitely the bit that's got the problem. And then finally the impeller, again, looks okay. There's no evidence on there that it's been touching anywhere. There was a lot of oil in the supercharger, definitely more than I would have expected to find had everything been okay. But otherwise, that's perfectly okay. Sort of rusty colour of this thing, this rotating guide vane, is because they were never plated. Most parts on the engine had zinc plating or other types of plating on them, but they didn't do it with these. Possibly on the basis that it was getting oiled by the tail bearing. I don't know, not honestly sure. Because actually, you would think that it would have a lot of water coming at it all the time, but they obviously didn't worry about that. There are two top marks there, centre punch marks, one there and one there. And these are what I was referring to in the previous video. They tended to stamp a little 0 on there actually, which this one hasn't got on it. So there'll be some marks on the main impeller that line up with these two, so that goes on in exactly the same position every time when it's rebuilt, because it was balanced as a unit. One more little interesting point about this impeller, and I don't think I noticed this when I built it in the first place, but that was like 25 years ago now. You can see that these blades are set in from the edge of the disc, and this is the conventional impeller where the blades at the same diameter. And if you look at my previous video of rebuilding the Merlin 20 Supercharger, it looks like this one. These blades were machined back, and they basically make the Supercharger slightly less efficient in reality. And it's used on, well, it was originally used on the Merlin 45M, and it was for lower altitude aircraft. One of them would be the Spitfire Mark V, LF Mark V. And effectively what it does is it enables you to have the carburettor slightly further open for a given power or a given altitude, and you want less restriction in the inlet tract of the engine. So in an ideal engine you wouldn't have a throttle at all, and that's why diesels are so efficient, or one of the reasons anyway. So just to summarise on this intake elbow, this tail bearing here was the root cause of the high oil consumption. Just to answer one of the questions from my last video, the oil supply comes in here, and it's a low pressure supply, which is up to about 10 psi, that's all, coming from the relief valve. And if you watch the video on the crankcase, the oil system relief valve is explained in there. Goes into the very back of that set of bushes in there. And then where this has been damaged and it's been repaired, there's a tube goes up. You can see the hole there in the top of the bore. The tube goes up, comes out of a second fitting on top of here, which goes to a breather, and that just goes to outside the engine cowling. Actually, nothing, you know, until it started to use a lot of oil, nothing really ever went up that pipe, because actually what tends to happen is most of the oil will get sucked into this part of the supercharger because there's a vacuum there. What they did later on was they deleted this breather fitting, and they put a fitting down on the side here. So what they were doing was actually drawing any excess oil down out of the bottom of the front of the bearing. I think it goes down through that web there, and then across and out the side here, and it went into a very small gear pump that was fitted to the bottom of the main oil pump. So as you might have seen previously on the other video, there are actually two floating bushes. There's a bronze bush inside the housing, which is pressed in there. So there's a bronze bush in there, there's this steel one, and you can see that it's got oil grooves which actually stop before they reach the front end, because they don't want oil coming out into the airstream. Bung that one in. Then we've got this bronze one with the same oil grooves in it. There's obviously a certain amount of oil contamination scoring on these, which won't have helped the wear situation. That one goes in there. And now I've got the supercharger shaft apart. This is the most interesting bit. You can actually see, although it was turning nice and smoothly when it was all assembled, and by the way, I fitted the supercharger retaining nut back onto the shaft, and you can see there, see that scoring where it's been touching inside here due to the wear in these bushes. And if I just bung this in, you can see there's also a fairly close clearance around that retaining nut. It's all intended to keep the oil back in that bearing and not into the airflow, but that's actually really loose. Loads of play in there. If I took the nut off, actually there'd probably be more play than that, and that was just allowing the shaft to lift up and down slightly. But it's another interesting thing even. This, I mean, the nut's got a bit of corrosion damage on it because it was the original one, but that's not the interesting point. If you look at where it's been, where it's marked, where it's been rubbing, which is around here mostly, why is it only on one side of the nut? So the only reason, because that side's clean, it's not been touched. So the only reason I can think that's been happening is because this nut isn't running true, which is a bit weird, because if focus. Everything on the supercharger has to run concentric and run true. So I totally understand why it was touching inside here. That's because of the wear on the bushes, but I don't really get why it's got that wear. And it's, you can see it's been getting very hot as well. It's blue in places. So I just caught that in time because the next thing that would have happened would have been that these blades here would have been machining their way through the casing. So it's all happy days really. Gonna get all this. Dan said he'll weld all this up for me properly. Then I'll stick it on the miller, clock it all up accurately off this register around here, and remachine it. I might just remachine the bronze bush that's already in there, and then make the two replacements to go in between that and the shaft itself here. And the shaft actually looks okay anyway, so there doesn't appear to be any damage to that. What I am going to do is I'm going to clock this shaft up and just check that it is actually straight, because if it's dead straight then it means that that nut must have been running out, and quite possible. I'll fit another nut on it anyway. So now let's go and watch the test run of the new supercharger, the first time we ran it. Enjoy.